All right, so this is for HVR155, week 4, lesson 2, afternoon class. What's going on?
What's up?
Not much, you know.
Am I the only one?
So far. We'll see. We'll see who else joins in in a minute. But today what I'm going to do is I'm just going to do this one lecture, and then we're going to I'll send out some videos that go along with it, with some questions and everything, just because it's a short one, and also my dog is being a total asshole right now, so she's acting all sorts of up. But
ooh, can I see your dog? I never got to see your dog.
Oh yeah, come here. Tanya, come here. Come here. Good girl. Oh, there she is.
Oh, so cute.
Yeah, she's a good dog. She just needs lots of attention, so there's that. But all right. Well, I'll go ahead. I'll get started on the lecture and everything. Oh, is that working? Yeah. All right. So if you're following along, it's going to be in your book on page 881 is what we're going to be looking at. We're going to be talking about ventilation today. Specifically, we're talking about ventilation for your flue gases. So, go back outside. Go back out? Yeah? Okay. She can't make her mind. So it's got a whole bunch of information in that section, 31.25, that talks about ventilation, and goes into some very specific things about it. One of the things is with modern furnaces, we're going to need ventilation for two things. We're typically going to have it where it's going to be a combination of, we'll have ventilation to get the flue gases out and to bring fresh air in for combustion. We've got it where there we go. Ventilation is really just the way that we're going to make sure that we have proper safe combustion and that we can get flue gases out. Part of that combustion process is the byproducts of combustion. Heat is one of them. That's what we want to keep in the house as much as possible. What we don't want in the house is the carbon monoxide, the carbon dioxide, the chlorine gases, all sorts of stuff that can be present, depending on the location of the furnace and what's the makeup of the combustion air for it. So there's a lot of different things that will go wrong with these. All right, so I sent you guys a video a while back, I think, when we first were going online. If not, I'll send it again today just because it's a good video. It goes over the different types of venting that we have. V-vent is your most common that you're going to see pretty much used nowadays. C-venting is still used in some locations and for some systems. So she's out. But the big thing with the gas furnaces is you've got it where depending on the temperature of the flue gas, that's what's going to change the type of venting you're going to need. So old school furnaces that weren't super efficient, they used a very thin walled venting called C-vent. It was very, very cheap, very easy to install. It's still used on some 80% furnaces nowadays, but it was easy, it was flexible. It didn't really need to be very precise or sealed. It was just, it trapped the gases pretty nicely, it carried them through, and it got them out of the building. And it didn't melt. That was the big advantage of it. C-venting was very, very good against high heat. And when you had an older, less efficient furnace, less efficiency means that your flue temperature is going to be higher than what was originally going to be coming out of the system or anything like that. You're going to have really, really high flue gas temperatures from a low efficiency furnace, while you'll have very low temperature flue gases coming from a high efficiency furnace. Because with the high efficiency, what we're doing is we're holding on to more of that heat. We've got more things to do with that gas now that we're holding on to more of its heat, but we'll get into that. B venting, you'll see, is like a two-walled ventilation system. I think your book's got it on, page 882, figure 31.9. It's got a section of type B gas venting. That's got it where it's basically got these collars on the end of it that will actually lock on and will link together each section, so it makes it really nice. But the other thing is you have those collars because inside of that B venting is a smaller pipe inside of it. It's basically double walled. And because of that wall, that interior of the piping, you have to have where it fits on very snugly. The tough thing with B venting is it's not easy if you have to cut it or if you have to customize the size of it. C venting is a lot easier for that. It's why it was used a lot more often back in the day. It's still used in a lot of places because, again, it's just easier. You don't have to worry about, what length am I buying and the collar and all this kind of stuff. You just have to, cut it together and snap it in place and put a bunch of screws in it. That's it. That's all we're going to have for our ventilation. For most of them, where it's going to be held together, it's either by some sort of ratchets or, not ratchets, rivets or screws are pretty common to see being used for fastening together the metal. Once you put one piece of venting together, you're going to have to, right around that connection, at least 3 screws is pretty typical to make sure that it stays on nice and tight. And why we do that is because if that sleeve is not snug against it, if that metal isn't really tight against it, you're going to have the potential for flue gases to leak out and go where we're not supposed to go into our chimneys, go into our living spaces. Those are be in the crawl space or the attic, where we don't want those kinds of things escaping, because not only are they toxic, but they're high temperature. And with a high temperature, if you've got it where it starts drying out a section of wood, or it starts eating up some mortar or something like that in a chimney, it can just be really catastrophic as far as the amount of damage it can cause, just because someone wanted to put 2 screws in instead of 3. They didn't want to secure it all the way down. You can also use a sealant as well to make extra sure that everything's good. There's a HVAC silicone you can buy that comes in, like, you use like a caulk gun, and you just beat it around the bottom of it and everything like that, fill in the gap, and it works really well. So that's another way to make sure that your flue gases are 100% exiting the structure. So there's a lot of different things that we can do to make sure that that's happening. But the biggest thing we have to worry about as far as the metal vent piping is condensation. Now, for the high efficiency furnaces, you've got it where it's that plastic ventilation is what you're going to see, and that doesn't worry about the condensation. If it condenses, if it has the flue gases condense into water, right? If it turns into water and it's got other trace, nasty stuff in it, acids and sulfuric and carbolic acid. It can have chlorine in it. It can have all sorts of nasty stuff, depending on a lot of different factors, mostly what the combustion air is being made up of. So when it's got all these gases that it's worried about and that are gathering up there and condensing, plastic's really not concerned. It's not gonna eat through it. It's just gonna fall right down into a condensate trap and then right down the drain line. So the big thing with it is you have with the old style with the metal flue piping, and this is something that I've told you guys about before. You can go to a job where the flue vent gas is, or the flue piping is just rusted out. It's gone. It's not there, and you need to replace it. And what's happened is, over time, combustion's taking place, flue gases are going up in that vent, all right? But somewhere along the line, there's enough gaps, enough little areas where our heat's going to transfer. It's going to go from hot to cold. So maybe there's a couple of gaps in the crawl space and a couple of gaps in the interior wall or somewhere in the attic or something like that. Or, you know, we have it where it's not completely sealed right there at the furnace. So it's just kind of leaking flue gases right there, just a little bit, just a little bit. What happens every time that it leaks flue gases out of the venting is the flue gases decrease in temperature. And as they decrease in temperature, that's when you're going to have condensation, which is going to eat through that metal. It's going to eat through that flue piping and that ventilation. It literally destroy it. You're going to go to a lot of houses and you're going to see them. It's just, it looks like a pile of rust if it gets really, really bad. You can test them and see if they've been damaged or anything. You really just got to, you know, touch the flue piping. If it feels solid like metal should, then it's fine probably. You can take a camera inside of there, you know, one of those little camera tools and stuff like that, snake it up inside of it and everything like that. If you feel like going that extra mile, but you know, you can squeeze it and feel if it's soft, if it bends, honestly, I've had it before where I just squeezed it and my thumb went right through the metal. And I was like, okay, well, that's bad flue piping. You know, and so it's just a matter of a couple of things to make sure that doesn't occur. One, make sure that the flue piping is sealed all the way until it gets out of the house. That'll ensure that you have less of a chance for the gases to cool off. Another thing that's going to help it is to reduce the number of turns and 90s that you have in your ventilation. Try to make it as straight of a shot as possible out of the attic. You know, try to make it go right out the roof, right straight up if you can. Now, a lot of times you're not going to be able to. You'll have a unit that'll be in a crawl space. It's going to be horizontal. So you're going to have to take it out a little bit, make a 90, and then go straight up if you can. I've had it before where it's been, you know, I've had to take it up, over, make a turn, add an angle, have it pitched, and then another angle, have it pitched for another 45 going up. And it makes it so that I know all those little turns are spots where it's going to lose speed, the airflow, it's going to slow down. And because that airflow is slowing down, it's going to cool off and it's going to condense. And in each 90, you have a higher chance of condensate gathering and eating through that metal than any other section of that flue piping, just because that's how it's designed. Now, for modern ventilation, one of the big things is chimneys. Most systems nowadays, you have it where they're not going to be vented through a chimney. They'll be vented independently. But older homes, especially here in Richmond and all over Virginia, or, you know, you ever go to places that just have older homes in general, you're going to see it where the ventilation is not going to be metal flue pipe all the way through the house. And that can be an issue. Most places make it where it's no longer up to code if it vents directly through a chimney, which means it just uses the same brick housing that you would for a fire, and it just uses that to escape flue gases. The problem with it is the chimneys and brick and everything like that, they are great for getting flue gases out of natural firewood fires, which burn extremely hot. Those are massively hot gases coming off of those, you know, a wood fire. If you've ever had it where you've had a fireplace or a working fireplace where you actually put in a big bundle of wood and everything like that, it gets toasty quick. It can heat up a whole room, no problem. But with the gas, with the flue gas coming from a gas furnace, it's not nearly as hot. So usually the masonry is either sized too large, so the flue gases can condense very easily on the walls inside, and they will literally eat away at the brick and mortar. And I've seen videos of houses that have had it where it's been such a big problem that the brick actually, the whole chimney just collapses off the side of the house, just because flue gases went out, cooled off, and they ate through everything. And that's just what occurs after over time. So most of the time nowadays, they're discouraging anything like that. If it's, you know, grandfathered in, they're usually going to encourage that you do something called a chimney liner, which is this kit that you do. It's like really, really expensive, but it's a liner that you put down in the chimney and you connect it to your ventilation directly. So that way, from your flue gas ventilation all the way up to the chimney, it's got its own independent ventilation. It's not going to come in contact with any of the brick and mortar, so it won't actually damage anything. That is the ideal way to do it. I got a buddy of mine right now. He does not have a chimney liner, and I have been telling him, "Ooh, God, for almost a year now, please get a chimney liner." And he just, you know, doesn't have the money for it. I get it; it's expensive. Again, flue gases, big thing we're looking out for is condensation. Can cause a lot of issues. So the high efficiency furnaces we've talked about before, they've got it where, because they're high efficient, they're going to have they're going to have multiple stages of heat. They're going to have multiple heat exchangers, that first and second stage heat, and that allows for you know, we've got that first stage, that big S-shaped section, and then it goes back into that one box, and then it feeds down, and you've got all those little tubes. This is like the worst drawing ever, but yeah. You know me, I'm addicted to the whiteboard as far as doodling, so this is the closest I can get. And then you've got your fan motor. Smooth gases up. And that's our flue venting. That's horrible, but so you've got it where so the flue gas, basically what it's going to be doing is it's going to be going out of this system. Is going to go through this first stage, the heat exchanger, through this second one. When we're talking about a high efficiency furnace, what it allows for is that second heat exchanger allows for the gases to cool down even more. And I just mentioned it with the chimneys, with the V-venting, with the 90s and everything like that. As it cools down, it's going to condensate. And this is, or it's going to condense into water. And we're going to have condensate as our byproduct. Now, usually metal would be eaten up by it, but it would be able to resist the high heat that is typical with flue gases. However, because we're retaining so much heat to the point where it's condensing all the water out of the flue gases just about, this means that the temperature is actually very, very low, about between 80 and 110 degrees, depending on the furnace and how it's operating. And you know, you'll have it where if it's 80 or 110 degrees, well, that's, you know, it can withstand that. PVC or HPVC. That's the stuff that can actually be able to withstand that temperature and any of the issues with the condensate coming and collecting on it. It's not going to eat through plastic. It can't really. Plastic is very, very strong when it comes to this kind of stuff. So, you know, if it was the opposite way around, if I had it where I kept the metal flue piping on for a high efficiency furnace, it would immediately start condensing flue gases on it and condensate, and it would just eat up and turn into a giant, you know, giant vent made out of rust, basically, and that would be annoying as hell to replace. If I put a plastic piping on a low efficiency furnace, it would not be able to handle it because it has it where there's such a high temperature, it would literally just melt the whole thing, you know, which would not work for us. Once it's melted, then it's leaking, then it's not working, then it's, you know, we're just stirring up the same gas over and over again and killing everybody in the house. So not a good option. again, like I said, the main thing is it's really interesting because everything can be plastic. It doesn't have to all be metal. But when you're dealing with the 80% or 70 or the low efficiency furnaces, everything, the fan motor, the fan blades, everything's got to be metal. But with the low efficiency, you can have it where the fan blades, the motor, everything can be plastic. Just because it's cheaper, it's easier, and it can withstand any of the condensate that would gather on it. If I had a metal fan blade, it would eventually rust out and would no longer be working. So category specifies correct amount of excess air. This is on the. There's 4 types of venting categories. I always forget about these. For page 882's got it listed there on the right-hand column. Category 1, furnace is a non-positive vent pressure. It operates at the vent gas temperature of at least 140 above its dew point. Category 2, furnace has a non-positive vent pressure, operates with a vent gas temperature less than 140. Category 3, positive vent pressure and operates with a vent gas temperature of at least 140. And then a category 4 is going to be less than 140 and above its dew point. So again, these are just talking about basically how hot the flue gas is going to be coming out of the ventilation, and that's going to determine what kind of venting we need. Like I was saying before, basically the lower temperature you're going to get that flue gas, the smaller piping you're going to be needing to make sure that the flue gas still escapes and can transfer going from hot to cold. But you're also going to have it where you're going to change the material because it may or may not condense into acid, which is what that water is going to turn into. Basically, it has acidic qualities to it. So that's the different stuff we're going to see with our ventilation. For gas piping, now this is the really interesting thing with gas piping. There's a lot of local codes. Sometimes it's going to vary from county to county. Sometimes it's going to vary from city to city. Or sometimes there will be statewide mandates that might be, for one area, but not, or for one state, not another. It gets very localized, local government kind of stuff sometimes with this. Usually it's pretty common sense stuff as far as what the codes are and why they do them a certain way. But for gas piping, you are going to have to, you typically get trained as a gas fitter. You've got it where as a gas fitter, you can actually, that can be all you do. It's just all you put together is gas piping for, stoves, for furnaces, for ovens, there's these cool things called salamanders, which are used in kitchens. It's like it's basically, you have a bunch of burners and they all shoot flames down basically. And then there's a tray underneath it that you can literally just with a lever lower and raise. But again, gas pipe fitters, that's what you're going to do is majority something like that. But for us, as far as gas piping is concerned, we really don't have to worry about that too often. You can buy your main gas piping material is going to be what's called wrought iron steel, WROUGHT. I'll write it out because I forget I can do that. So wrought iron steel is pretty much the most common as far as your gas piping is concerned. It's what a lot of things are going to be using to carry natural gas and propane. The other thing you're going to see is what's called yellow flex gas line. And this is one that typically is going to have more restrictions on it. So things for regular wrought iron steel gas piping, you're going to have to pay attention code-wise are, every so many feet, if it's not, connected to a bracket or a wall or something like that, it's going to need a support strap somewhere along the way. Usually it's, some places it's every 18 inches you have to have support for that gas line, which makes sense because you don't want to have it where some part of the gas line just starts to sag or is a low point or is a heavy spot or anything like that. You want to have it where it's nice, fixed, straight, right across carrying that gas. throughout a building. So wrought iron steel is going to be, again, like I said, your main piping that you're going to see used for that. For HVAC purposes, it's really nice and easy because manufacturers and parts warehouses have it where they sell it, and they sell it in increments. So you really don't have to buy, you don't have to thread your own pipe all the time. You can have it where you can just buy it. You can buy it in the pre-cut lengths with threads on the end of it. And the threads are really annoying to get them like just perfect, because you have to have 7 perfect threads, 11 threads overall. It's like this really weird combination. The threads have to be tapered, which means instead of just being a pipe that's straight with threads on the end of it, it'd be a pipe with threads that just barely make it kind of a cone shape on the end of it. So it's kind of difficult when you have to do all that on top of trying to just make sure that the gas line gets to the furnace. When you're installing a new gas furnace, the main thing is making sure that you're putting pipe dope. Make sure that's your sealant that's going to be used on your threads. Make sure you're putting that on every connection. Make sure you're having good tight connections. Use a set of pipe wrenches. They're an easy set of tools you can buy. They don't cost that much. You can buy them. I brought those ones that I had the other day where they were aluminum. I don't know if I brought that in for y'all's class or if that was different one, but you can buy them. They're either usually really heavy steel, or you can buy aluminum ones that are a lot lighter, but they don't have as much weight to them. So it's your choice as far as what you want to do, what you want to carry around in the tool bag and everything. But one of the big things as far as codes are concerned here in Virginia that I know is pretty much universal in most places is with gas piping, if you've got it where there's a furnace housing, all right, and we've got our gas line coming in at the top here, all right, when it comes through this section right here, all right, so here's our gas line coming in. I don't know if you guys are hearing all this construction going on outside my house. They were redoing my road. The gas line's coming in. It goes in. When it goes through this wall, this housing right here, it has to be wrought iron steel solid pipe. It cannot be flexible piping. Flexible steel piping is good to get things around corners, through floors, well, not through floors, around corners, in weird spots in an attic or something like that. But it is not a safe way to get gas through that housing. The reason why is if that housing moves or shifts in any way, it can cut that flexible line very easily, and then you have a gas leak right next to your combustion, which means really big explosion. This is kind of the stuff that you're going to see, you've got to just watch out for. And certain things you're going to pick up on, you're going to hear from coworkers, you're going to learn when you first start out, especially if you go into installs, you'll really learn because they'll usually have a lead installer and they're going to know, oh, I know all the state and local codes because, I'm being told, what to do. I've got the information. I've been doing it for a while, hopefully. And even if not, most of the time they'll have it where like a company will give out a standard where it'll say, okay, if you're in this county, watch out for these such and such kind of thing. Or you'll just learn from your coworkers and say, hey, look, this seems like a little weird as far as how they've run this gas line. Is this up to code or is this against code? And they might be able to help you out. Again, piping, we're going to keep pretty simple. We don't have it where just like our flue venting, we don't have a ton of 90s and a bunch of turns and everything like that. We want to get as a direct line as possible of our gas to flow into our system. If anything, we want it flowing down to our furnace and then over to it. So that way that anything that happened, anything in that gas that might not be natural gas that might be mixed in with it would be able to be collected in a sediment trap. Usually you've seen those probably if you look around, if you've got any gas appliances in your house, anywhere you've got the gas line hooked up, just about right at the end of it, right before it hooks up to the appliance, there's usually a T connection. And at the bottom T, so you'll have this going to your appliance, so your app. and then you've got this line is your main, and then you'll have this little cap at the end. It'll be just a straight piece. It'll be just a cap on the end of it, and that's going to be, if anything is in that gas line, whether it's rust, whether it's debris, anything that could have gotten in there over time, or any stuff that gets in the natural gas, itself, we'll be able to collect at that bottom, and you can actually empty those caps and make it so that there's, you clear out the gas line basically. What you want to do that though is you're going to need to shut off the gas at some point prior to this, somewhere where this main is. Sometimes you'll be lucky and there's a gas shut-off valve right here, but more often than not, you're going to have to go and shut off the main gas. You got to talk to the customer, let them know what's going to happen, because they might be trying to cook their lunch or their dinner or their breakfast, or just a snack. They might be in the, they might got the munchies and be like, oh, I need to get some mac and cheese, man. You're like, hey, no gas for a minute, just hold off, and they'll get through it. They'll be fine. And there's microwave mac and cheese anyways. They can learn these things. We've got it where gas piping is going to be really important. So pipe dope is what I always recommend to use. Teflon tape is good for gas pipe connections, especially for propane, but pipe dope is usually a little more reliable, and it's easily seen visually, so a customer knows right away, okay, yes, I've got it, there it is, we're good. They can see it deteriorate, they can see it change color typically. It'll go from, a nice crisp white to kind of a, gray and then a yellow, and it just kind of discolors until it looks really nasty. Like, hold on a second, that doesn't look like it did 3 years ago or 5 or 10 years ago. That becomes a problem if the customer's only been living there for, a year, and they're like, oh yeah, it looks like it has when I moved in, but okay, well, that's deteriorated. We need to reseal it. Resealing, that's another thing besides, like I was saying, shutting off that main gas line, emptying that cap. Also resealing your gas lines, making sure you've got good connections that are clean, they're making good connections. You've got enough pipe dope on them to seal it up, so gas isn't leaking out, because that wastes energy and it's also dangerous. My sister, I've been trying. I need to get over to her house and fix hers because she's got a couple of small leaks, but it's to the point where I just like looked at it. I was like, yeah, I'm gonna find a leak if I put a detector on this, or if I spray it with a bubble solution. So usually that's one of the easiest ways to check for leaks, is just you spray down all the connections with a bubble solution. Usually it's like ammonia and a couple other things, but it'll detect. Well, what'll happen is it'll sit there on the connection, and then if there's a leak, it'll blow up. You'll see a bubble just boop and it'll pop, but it'll keep blowing up a bubble. If you ever looked for a leak on a tire with a soap solution or anything like that, it's the same exact process, same kind of idea we got with it. So again, piping the furnace and fire drip tap, that's what I was talking about. Shut off valve and some sort of connection. The shut off valve is really important to have. It makes it so that you can operate the system safely, and it helps you as a technician for troubleshooting to cut down on your time. If you have a customer and you go to their house and you're just doing a maintenance call and they don't have a shut-off valve, offer to install one for them. And explain to them that if you come out there again, that it's going to save every other technician that has to come out there for major repairs from having to shut off gas for the whole building or something like that, or to the whole home. Sorry, my dog is being really, really weird. Okay. But yeah, you're gonna basically leak test all of your connections when you do an install, make sure that it's working properly. And the last thing you want to have is, a gas line just leaking like crazy. So leak test, like I said, you're gonna have it where there's a couple of different styles of them. The soap and water test is an easy one. But a manometer can also be used on what's called a lockout test. So if you've got a gas shutoff valve, all right, what you can do is you can hook up your manometer to your gas valve inlet pressure, and you shut off the gas line, and then you just watch your manometer. And if your manometer starts to lose pressure, then it's got it where there's a leak in the system, because it's no longer just that gas in that line. Because if you shut that off and that gas in that line stays there, it should stay at that pressure for at least 3 minutes. That's what you're going to be looking for. If you do it for 3, you're fine. Do it for 5, you're extra fine. You'll know if you've got a leak going on with that. Usually a manual manometer is pretty popular for using this kind of testing. This is how it would be for when I worked on RVs. We did the same exact thing for the propane lines. We would do a leak test to make sure that the entire system was leak proof, because it was a major concern. If you have gas leaking, it's a huge problem, and it's a minor repair. That's the crazy thing about it. Huge problem, easy fixes. Unlike some of our other things we have with air conditioners. So purging the system again, you're going to have it where you want to make sure that you're ventilating outside, make sure you've got a fan set up if you need to and everything like that. You're going to try and basically get the gas out of the lines that are in there. You know, one of the easier ways to do it is to, this is saying, you know, just, hey, let the gas basically escape from the system, and then ventilate it out of the building. Another way is to shut off the gas and then turn on the furnace and try to get it to basically burn up all the excess. But even then, there's going to be residual amounts of natural gas stuck in that line. So you will have to make sure you ventilate properly, because otherwise you're going to be working, and the whole time you're going to think, oh my gosh, I'm going to catch something on fire if I, you know, have a static shock spark or something. You know, so because it's going to stink like rotten eggs. So that's one of the things you want to make sure you do with the system if you're going to be taking apart any of its natural gas lines. Burn out the gas that's left in the line, and then have it where you're ventilating anything that might be left in the line. So that's pretty much it for today. What I'm going to be doing is I'm going to send out a couple of video links with some questions for the next hour, just to show you, just for y'all. And then that's all I've got for today. And I'll see y'all tomorrow afternoon at 3. No, y'all, I think I've got at the right time. I've got y'all at the same time, 1:30, 2:30. So double check your emails. I sent out all those Zoom links that's got everything for y'all. And I will see you then. But I'll upload this video and send it out as well, unless you guys got any questions.
How about the homework, sir? So I've done from number 13 to 24.
Mm-hmm.
Do you email that homework to you?
Yeah, you can just email the homework to me. Yeah.
Okay.
Yeah, that works fine.
So you said you'll send us the YouTube videos to watch?
Yes, I'll send those out right away.
Okay.
Yeah.
Okay.
All right.
So do we have any quiz tomorrow or no?
Yes, there will be a quiz tomorrow.
Okay.
Yeah, I'll have that. I'll send that out probably tomorrow morning, and then give you guys until Sunday night to finish it.
Okay.
Yeah.
Okay. Thank you, sir.
All right. Thanks, guys.